Alright, hi Year 12s, this is Mr. Lim here again, and this is a special request about a question from the exam, question 41 from the 2014 exam, so let's go through it. So we're dealing with this rock phosphate as a non-renewable source of phosphate fertilizer, so we're looking for phosphates. Rock sulfate is one of the sources, but let's go look at another source, and the great source, and we'll color it in yellow, is urine. Alright, so urine isn't a renewable source because everyone makes it, so the phosphate in urine can be precipitated out as calcium hydroxyapatite, right? And struvite, as the pH of the urine increases, the pH increases due to hydrolysis of the urea in urine into ammonia and carbon dioxide. So write a balanced equation for the hydrolysis of urea. So here is your urea. Okay, it's quite interesting. So what it is, it's a CO surrounded by two NH two groups, so CO with an NH2 group here and an NH2 group here. Okay, that's going to hydrolyze with water. It's going to accept, because it's got two amide groups on there, and so therefore it's going to accept a hydrogen. We're just going to draw it accepting one hydrogen and turning into a positive. Oh no, whoops, I haven't put a positive in here. Right, and so there's the reaction there. The CO NH2 plus H2O goes to CO NH2 for one side and the NH3 for the other side and an OH minus. Okay, so explain briefly why the hydrolysis of urea causes an increase in pH. Okay, include appropriate balanced equations. So number one, you're saying it produces OH minus ions. That makes sense, right? So that's the first part. Those OH minus ions react with the H plus ions. So this is your balanced equation to show that it consumes the H plus ions, because pH is what it's talking about, and the HI plus ions are what the only way to change pH. So you got to say why those OH minus change to the H plus concentration. Right. So that's that answer there. Now this one was quite interesting. Determine the phosphate concentration in urine. Collected 5 liters of urine. Yeah, that's a lot of urine. And allowing pH to increase to about 9 to adding excess magnesium ions to precipitate everything out. It made 25.3 grams of a mixture of calcium hydroxyapatite and struvite precipitate. Analysis shows that the 82.3% of the mass of precipitate was struvite and the rest was calcium hydroxyapatite. Determine the concentration in grams per liter of the phosphorus in the urine. Now, there's a number of different ways to do this. I've chosen to go by percentage composition. Okay, so the idea is that this calcium hydroxyapatite and the struvite are part phosphorus, part everything else. So if I can work out what the percentage of phosphorus is in these two substances, I can work out their masses, and then since I've got that mass, I can work out it in grams per liter, especially because it didn't ask me to work it out in moles per liter and instead asked for grams per liter. I might as well stay in grams. Okay, so first of all, I applied the 82% to the struvite, and I got that mass of struvite and that mass of calcium hydroxyapatite. All right, that's the first part. So once I did that, I worked out the percentage of phosphorus in the struvite. Okay, so the percentage of phosphorus in the struvite, there's only one phosphate in the struvite here. Okay, only one phosphate in the struvite there. So it's one of those phosphates. It's a 30.97 over the molar mass of struvite, which is they've conveniently given you there, right? Which is very convenient, right? And they have also given the calcium hydroxyapatite, so I did the same thing there, but instead now it's got 6 calciums in there instead of just the 1. So don't forget to look at what's the ratio between those, the whole substance and the element that you're looking for. And then I got my 2 percentages. Okay, so those 2 percentages, you can totally write it like this, because as long as you are showing what letters you are using, you can show your calculations using letters, because, hey, algebra, right? So I took the C value, multiplied it by A. C value over 100 turns into a percentage. I get this value. D value over times B value over 100 gets you this value here. I added them together, and then I get the concentration in grams per liter, remembering that it's 5 liters is what you started off with. Okay, so that's that question there. Right, let's have a look at the next one. Explain using collision theory why increasing the pH of a phosphorus depleted urine converts the ammonia into ammonium into ammonia. Right, so ammonium into ammonia is the acid turning into the base form. Okay, so increasing the pH increases the concentration of OH minus ions. Okay, so that's what it's asking you about. Why does the increased pH do this? So those OH ions, what do? They react with the ammonium ions in this reaction, because it does ask for a reaction. I would have put the states in there as well, probably, just in case. Right, but that's the equation to convert ammonium ions into ammonia with the OH minus ions. And then it does say using collision theory, so I had to put in some collision theory stuff. So increasing the concentration of OH minus ions increases the frequency of collisions, and thus the frequency of successful collisions, and thus makes the reaction go forward or favors the forward reaction. All right, this is an old exam. I can't remember what they were going for at this point, but the idea is that you had to talk about frequency of collisions, I'm sure, and frequency of successful collisions, if you wanted to get the marks for using collision theory. All right, let's move on. What's the purpose of heating the solution to 40 degrees Celsius? This was back in the day when we did latent heat of vaporization and stuff like that. So effectively, it's to provide energy for a change of state to turn it into a gas. Once it's in a gaseous form, you add it with sulfuric acid, as in step 3 on the page before. And that's the equation that you get. The NH3 gas and the H2SO4 turned to NH4 2 sulfate. Now, is this an ionic equation? No, it's not, because I've kept the sulfate in there in aqueous form on both sides. So I could have turned this into an ionic equation if it asked me to, but I didn't. Okay, and then this is the tricky part. The amount of ammonium sulfate recovered from the 5 liters of urine was 72.65 grams. If the process is 78% efficient, what is the concentration of nitrogen in grams per liter of the phosphorus depleted urine? Okay, so the point is that lots of people are having trouble with the idea of this percentage stuff here. All right, so we've really got to make sure that we understand what we are looking for. This process has taken 5 liters of urine and made 72.65 grams of ammonium sulfate in a 78% efficient process. So what does that look like? We can draw it over here. Here's your 5 liters of urine. Okay, it's turned into this mass of stuff, which is 72.65 grams, and it's 78% efficient. Okay, that's the information that we have. What's unknown? Here is where we start. We start off with the powder here. So this is our known. And we are going backwards to work out the concentration there. If we are going backwards, we are not going to apply that 78%. We are not going to apply that 78% in the forward way. We're going to apply it in the other way, which means that we're looking for the 100%, not the 78%. Okay? So since we are going with trying to get the 100%, because this value that we've been given, the 72.65, is the 78%, we need to work out how to get the 100% from the 78%. So let's go look at the calculation here already. Okay, first of all, you work out the number of moles of the ammonium sulfate to get that one there. Oh, I've done that wrong. No, I haven't. So you work out, because what it is I was thinking that this was an impure substance, that this ammonium sulfate is the impure substance, but it actually is a pure substance. It's the process which is 78% efficient, not the process makes a 78% pure substance. All right, so this 72.65 grams is pure ammonium sulfate. And then you have to work out what's the 100% process of this one there. So you can work out the number of moles of NH4 2SO4, the ammonium sulfate, as that one there. Once you have that, you can work out the number of moles of nitrogen via the idea that there's only 2 nitrogen atoms per ammonium sulfate. Once you've got the number of moles of nitrogen, you can work out the mass of that nitrogen, which is 15.4 grams. Okay? So that 15.4 grams was produced at a 78% efficiency, right? If it was produced at 100% efficiency, it would be 19.75 grams, okay? And because now it's at 100% efficiency, that's the amount of nitrogen that would have been in that 5 liters at the beginning, All right, so the amount of nitrogen in that 5 liters at the beginning is that 19.75 grams, and therefore you can do the 19.75 grams over the 5, and that will get you your answer. Okay, so that's it. We'll see how we go.